Hello and welcome to the Cloud Foundry Summit. My name is Rajesh and I'm going to talk on microservices observability in Kubernetes. Focus of this session is to show you the steps to achieve observability using open source tool. Before we get into the details of the topic, let me introduce myself briefly. I have been part of software engineering field for more than 2 decades now. Currently, I'm working as a CTO for a tech startup, and earlier to this, I was part of Fortune 105 companies, JP Morgan, Deutsche Bank, and Morgan Stanley. So this is the quick brief on the agenda. We will check the definitions. We will also look at the 3 pillars of observability. We will take one example, microservices example, and we will do the observability setup using open source tool. And then we'll summarize our discussion and we'll take the questions post that. See, there are many definitions found. The closest one that I have found in control system, the way it states is a measure of how well internal states of a system can be inferred by knowledge of its external outputs. In a nutshell, what it means is adequate insights into the system facilitating corrective action. So there are 3 main pillars of observability. First one is event logs. These are nothing but the records of events that happen in the system. Events are discrete and contain metadata about the system when they occur. Second one is distributed tracing. Most of the system, they usually consist of many parts and components, and these parts and components, they work cohesively to provide certain meaningful functionality. And for a particular functionality, tracing of a request and response flow across distributed components is critical for effective troubleshooting and debugging. So that's the second pillar. Third pillar is metrics. Performance of the system is measured over a period of time in terms of metrics. These indicate the service level of a system. We'll look at the application level metrics as well as cluster level metrics. I have taken one example using the app, weather app. Weather app is split into 3 microservices. The first one is the user interface, that is the front end. Second one is the middle layer, service layer, that actually talks to metaweather.com to get the city specific weather information. And third one is the database. I'm using cluster built using kubeadm. Cluster has got 1 master node and 2 worker nodes. Master has got a couple of core and 2 GB RAM, and worker nodes, each worker node has got dual core and 3 GB RAM. So all these nodes are virtual nodes created using background. And to do the observability setup, I'm using open source tools like Fluentd, Elasticsearch, APM, application performance monitoring from Elasticsearch, Kibana, Prometheus, Grafana, and Helm to set up some of the tools in Kubernetes. Master node here. So I'll directly add the repo. Let me update the repo. Okay. Now let us create the Kibana as well. Elasticsearch as well as Kibana, both are running. So now let us install Fluentd. So Fluentd is the log monitoring tool. So we will use the Fluentd to get the log, extract the logs and send to Elasticsearch server. For that we have 3 total YAML files. One is the cluster role binding for Fluentd. Second one is the configuration file for Fluentd and the config map for Fluentd. And now finally the Fluentd. Okay, so let us wait for a few moments till this Fluentd comes up. Now Fluentd is up. So now we can set up the next tool, that is the APM, application performance monitoring for distributed tracing from Elasticsearch. Okay, that's also running. So now we can install this Prometheus and Grafana. We'll do this via Helm chart. So this is the master node. So we're adding both the charts, Prometheus as well as Grafana charts. Once those are added, we'll do the Helm report. And now let us install the Grafana as well. Now Prometheus and Grafana both are deployed now. So now now this is the right time to deploy our microservices. The first microservice that we'll be deploying is the database. So here is the quick view. It's a simple MariaDB based microservice. Okay, database microservice is now deployed. Let us check if it is up. Okay, that's running. Let us deploy the next one. Before we deploy that, let us have a quick view on the configuration. So this is the service definition for this microservice, and this is the deployment definition. You can note down as part of the deployment definition this particular section, annotation section. So this is used to send the metrics related information to Prometheus. And below that you can see the init container. So this init container has got the APM agent, and this particular APM agent is used by the Java configuration or the Spring Boot microservice with their services to send the APM related information, distributed tracing related information to the APM server that we deployed some time back. I hope you are clear on that. So these are the two insertions. One is the metrics information to Prometheus. Second one is the distributed tracing related information to APM server. So without making any modification to the microservice, we have only added the configuration, Kubernetes configuration, to get this additional information, distributed tracing as well as metrics information. Log information is anyway pulled by Fluentd daemon. For that also we did not do any modification to the microservices. So now let us deploy this weather services. So all the event logs are shown here. You can filter by particular pod. You can see all the microservices information, also their log information. So this is the first pillar of observability, to have the event logs. Now let us look at the traceability. Click on the APM under the observability. So here you can see both the microservices. These are the two. In order to get some logs for distributed tracing, we need to use the app. Let us say we want to get the weather details for the Bangalore city. Yeah, once we start using app, logs will get generated, and also the trace ID for microservices that will also get generated from one microservice to another microservice call. Okay, so here, if you click on this particular first trace, at the bottom you can see the distributed tracing. So now you can see it here, from one microservice to another microservice. This is the call from the first microservice, that is the front end microservice. If you click on this one, you can see more information. You can see this trace ID, and this will be common throughout the trace. You can see the overall time. Coming to the third pillar of observability, that is the metrics. Let us first set the data source as Prometheus. Now let us import few Grafana dashboards. So this is mainly meant for Spring Boot based application. Okay, you can quickly see that for this particular microservice, we already started getting some data. You can see the uptime, you can see the heap use, we can also see the GVM related information, CPU information, loading. Internal sub-JVM memory pools, including garbage collection information. Here you can see information on the cluster for the selected node, CPU, memory, system load, including the network information, internet traffic for various interfaces. Open file descriptors, network socket information, we have seen event logs, we have seen distributed tracing, we have also seen application metrics as well as cluster level metrics. So now, using this setup, you can easily do the observability setup for your own microservices. That's the end of this session. Thank you very much for your patience. You can reach out to me using these coordinates. Thanks again. Have a nice day.